So let's continue. This is the fracture geometry. I've wrote it to disk. This is the first part and this is the second part. And what I'd like to do at this stage before doing any complex RBD sim or anything like that, I'd like to test the geometry and make sure that there is nothing wrong with it. And what I'm going to do now is I'm going to delete everything, groups, attributes, all that stuff. Okay? And clean up the geometry. Actually, let's merge these two guys first. And this. I'm going to delete all the groups and I'm going to delete all the attributes. Okay. And now we have just B. And I'm going to pack this. So assemble node. And I want to create pack geometry. I'm going to create a null and call this out RBD. And let's create a dot network. RBD sim. I'm going to give this red color. And it's a new feature in Houdini 17. If you copy the node, it's going to copy the path of the node. So it's very, very helpful. And let's create the few things we need. RBD packed object, bullet solver, merge node, gravity node, and ground. And let's connect them up. And here I'm going to paste that path and create active RBD object. And let's go back to the first frame. Cool. And all I'm looking for here is to I don't want to see any jumping. I want to see any explosion happening. I don't want to see any weirdness with this simple sim. So I would expect everything to fall and crumble accordingly. Now, obviously the scale and the gravity is still a bit off. And something that I do with Bullet is I increase the scene scale quite a bit, generally 10 times bigger than what it is supposed to be. And this helps with everything that is a very small object, and it also helps with selling the scale when you want something really large. It's much easier to control it this way. So I tend to increase the scale of the geometry before I pass it into the RBD solver and then scale it back at rendering. So this is working. Let's check how many pieces we have. So we have 14,000 pieces and everything is looking great. Let's do flat shaded. Yeah, we can see the wires on the packed primitives, but everything is looking great. Cool. All the pieces are individuals and are separate. I'm not seeing any issues with there. So with that, so the naming is working, connectivity is working, and there is no explosion or anything like that. So I'm pretty happy with what we have now. And what I'm going to do next, actually, maybe, yeah, let's do it now. So I want to set up a simple constraint system for this. So I'm gonna turn this off. I'm gonna name it here. So we have the data name. I'm gonna use a connect adjacent pieces. I'm gonna change this from surface points. So it gives me the centroid. And so there, this here, I think there is an issue with the mesh, the fact that they're coming all to this point. I think there is something wrong with the mesh. So we have to see that because when I look at this, actually I think it's fine. Yeah, because this piece is concave. So this piece, actually let's do it here. So one of these guys is a concave piece. Yeah, this geometry here. Actually, let's remove them. or let's remove one of them to test this, and I will explain in a second why this is happening. Okay, let's delete that. And we still have the interior faces. No, it's gone. Okay, so let's do the connectivity with these guys. Let's take a look. So it's fixed here. And the reason for it happening is if we take a look at these big blocks, this one for example, let's move it out. The centroid is here. For this entire piece, the centroid is here. So what I would probably do is go back to this specific group and fracture it even more, so we don't have these kind of elongated shape. Actually, they're going to cause some issues with the destruction, so that's why it's giving us that weird connection, but everything is working fine. So let's set up some properties. The RBD constraint property node helps with setting up a few things for us. And we need to pass it through the constraint, unfortunately. So this helps give it the constraint name, attribute, constraint type, and the name is glue. I like to use lowercasing so I don't have to worry. Actually, I use lowercasing with everything. No camel casing, no uppercasing. And the same thing we could have done obviously through a wrangle node. And we need as constraint name equal blue, and then the second one is as constraint type equal all. So these are the two main ones that we need. And let's use this out CST for constraint. I'm going to copy this node, and it's in the Control C. Now I hit Control C, so it's in the memory. And if we go inside, I'm going to paste the path for this node and the constraint, which we haven't created. So let's put down a constraint network. And I always do, this is my process for the destruction. I always start with the bare minimum, test, make sure the geometry works, and then I add the constraint, generally the glue constraint, which is the easiest to test. And then I start adding on top of that to make sure that there's no issues with any of these steps. So here, sorry, this path. Yeah, I did paste the path, and here the name is glue, and let's set this to 1000, and let's turn on the cooking again. And if we display guided geometry, we should see the glue network. We should see the connection. So the fact that it's not doing that, it's not showing us the relationship, it means there's something wrong with our setup. So let's see what's happening. So here we have the name attribute, that's correct. Here we have, I could be missing something that you guys are seeing and probably thinking, why didn't he figure this out yet? But I need to go through the steps. Okay, so let's check. That's the constraint network. Yeah, everything seems to be correct here. Oh, I know why. So when I untick the packed geometry, it's not packed here anymore, so we need to put down another assemble node and turn these off and pack the geometry. So now, yeah, it should work. And if we hit play, something is happening because the geometry is heavy and the constraint is not that big. You can see it's holding up. Just the weight of this area is pushing it to tilt this way. some pieces escaped there. And let's see what's gonna happen now. Yep, everything is working. We have our constraint network, and obviously we need to make few pieces, at least the left and right side, static, so it doesn't swing just like that. Okay, cool. Now the next thing we're gonna do in the next few videos is to add the animation Kong. And we're going to take a look at what is the best way to use complex geometry and create a stable collision from that. And that's it for this video. See you in the next one. Bye bye.